Hello, hello, hello. Just make sure I'm actually live here. Wait for some people to filter in, yada yada. Same as always. Sorry about the lateness. Had some issues getting some stuff set up. And as always, wait for the website to update as the true test. In the meantime, how is everybody today? Hope you are doing well. As well as you can be. The website does take a minute to update, doesn't it? Sure that everything is working. It says Twitch is working. Oh, you know what? I wonder if oh no, Twitch is actually working. For a minute there, I wondered if it was sending it to the wrong channel, or trying to. I don't know if you noticed, but on Twitch's end, I changed, and YouTube's end as well, I think. I changed my channel names and things. It's a bit more put together. Instead of having channels and stuff named like, you know, Eggies or whatever, they're all named the same, Egg82. Alright. Excellent. Looks like everything's up and running. I'm going to have to move over slightly, but let's see if I can get this over here where I can actually talk into the microphone a little. Alrighty. Hey, it's a Moonblocks. How's it going? Well, that's good. I'm glad you're doing all right. All right, so here are the tools that we're going to need. Some of the tools. You got that? Skizzers. Yeah, I am. I set up the camera in a new position, so that way I can actually work on this kind of stuff in my usual spot. It's a little bit smaller. Unfortunately, I don't have a huge bench, but I do have something. Yet. Oop. There we go. Very nice screwdriver set. Alright, enjoy your exam. Alright, let's undo some of the stuff that I did previously, because I want to try and redo this from scratch. Try to. So I've got a 12 volt power supply that 12? Yes, this is 12. Got a 12 volt power supply that I can plug in. I've already done these screws here at the top, and it actually connects to this.
Margarita leaves with the chemistry exam.
Perfect. So this is a not a transformer, I'm sorry, a bridge rectifier is what it's called. So it takes AC and converts it into DC. And this particular one converts it into 12 volt DC. Max output is 12 volts at 5 amps. And in order to get wattage, you just multiply the two together. So that's a maximum of, I think, 60 watts? Should be 60 watts, if my elementary math is correct. So it should be plenty for our purposes. And by our purposes, I mean, let's see if I can, should be some stuff in the drawers here. For our purposes, I mean this. And actually I have one already kind of wired up a little bit here. One of these guys. So this is a magnetic lock, or a Maglock. So, if I plug this in, and let's see, I don't know if you can see this, but there are markings on the top here, and hopefully I can show you that. But those markings on the top kind of indicate where things go. In this case, the neutral or negative or ground, whatever you want to call it, is this guy. So I'm just going to very temporarily wire them in and kind of show you how this works. As soon as I figure out a place to plug this in, something I didn't actually think of. Yeah, that's a problem. I'll be right back. Alrighty, sorry about that. Alright, so this should be plugged in. So if I take this hot and touch it, you should see that this guy right here goes in and out. Every time I do that, I'm shocking my headphones, so that's not good. Ah, interesting. Same as some of the current passes through my body. That's not good. Anyway. So this should be a relatively stable 12 volts. Let me just double check that it is. With the multimeter. Probably should have done that before I plugged in the thing that consumes 12 volts, but hey, doesn't matter. Do I use the crocodile clips on these? Not sure how to get these in here, so probably not. Question is, what do I use? The answer is is I'm not quite sure. Ah. Maybe this? Not actually sure. Maybe not. Let's see if I can actually use the crocodile clips here. I do positive. Oh wait, maybe I can. If I get this up enough. That's what she said. I went there. Okay. Let's set the multimeter next to it and see what kind of current it's, or not current, see what kind of voltage we're getting. That should be it. Alright, getting just over 12 volts. 12.03 volts. In fact, let me flip the camera around so that we can actually see it. And now it's backwards. Interestingly, I can't seem to flip it horizontally. Let's see here. Just so it's easier for you to see on the screen. Doesn't seem to want to let me flip it horizontally. There's just a vertical flip. I'm not sure why you'd want that. Why would you want to flip things vertically without flipping it horizontally? Does that not make sense? It would be backwards, wouldn't it? Well, that's not good. Well, my apologies if you can't read upside down, but that's about 12 volts, 12.02 volts. So that's good. Alright, we'll shut that off. Watch the voltage go down as the capacitor inside dies. One of the two large capacitors in there. I don't know if you can see those. They're right here on the edge. Alright. Oops. Alright, so this should be about 12 volts. Now, what I want to do is I want to power not just the Maglock here, but also an Arduino Uno right here off of it. In fact, I think what I want to do is maybe power one of these guys. The really tiny Arduinos. These are off the ATtiny85 chip. Or these are the ATtiny85 based chip. Which is strange because there's a lot of pins there. And you would think maybe that's like an Amtel? I don't know. It's so the website kind of Pot Noodle Live teach me. Well, that's kind of what I'm doing right now, I guess, right? Is that not the point of this stream, is to kind of like teach and learn, right? I'm learning too, so. So this guy right here it's interesting because the website says it's a AT-Tiny85 based chip, but I have AT-Tiny85 chips right here. And you can see they have 1, 2, 3, 4, 8 pins, and 2 of them are for 5 volts in, and 1 is for ground. So, or 1 is for 5 volts in, 1 is for ground. So 2 of them are reserved. So you only have 6 pins to play with. This, on the other hand, this thing has, I don't know how many chips, or how many pins in it. There's a lot. So I'm kind of curious as to that claim that's based off the AT-Tiny85. Hey, do you still code for people who own gaming servers? Not really, no. I've kind of moved on. I mean, you know, if the pay is good, I'll do whatever, but generally, no, I don't really do that. I've got other things that I do instead, like this, for example, streaming. But yeah, so it's interesting that we do have two positive, negative, a positive, and a negative here as well. And the board is actually, you can power it off of USB and program it, of course. And there's only 6 pins here. So that would seem to fall in line with the AT-Tiny85's pinout, right? But I don't. And there's a couple of pads down here too. So, and more pads up here. So it's a little bit strange. I don't know. Maybe that's UART? This could be UART. I think it'd be fun to program one of these. I'm not sure if I want to. I think I want to prototype on this first. These are good prototyping boards. The AT Mega. And so after that, we'll move it over to this board here, I think. That sounds like fun. So ultimately, we want to move these out of the way. Ultimately, the idea here is that we want to take, let's see if I can, here we go. Take this guy, which is an RFID reader and writer actually. It works on the 13.3 megahertz range. And I have a bunch of tags for it, so I can just scan those. But we want to take this guy, plug it into here somehow, right? Into the board. Do some processing based off of what this reads. And then open or close this on the end. And so, one of the ways that we're going to accomplish that is, again, with this power. There's a couple of problems. One, this doesn't have a signal line. It's just 5 volts and negative, right? So if you want it closed, you power it, you give it 5 volts, 12 volts. If you want it closed in, you want to give it 12 volts. And if you want open, you don't give it 12 volts. Simple as that. And the second problem is that this board runs off 5 volts, not 12 volts. If I feed it 12 volts, it will explode. So let's not do that. So the question is how do I do these two things? Well, one, they're actually both fairly simple if you really stop for a second and think. So one can be solved with a buck converter. Now you can do this with transistors as well. I actually do have a few power transistors for something like this, but transistors are super inefficient and they put out a lot of heat, especially if you put 12 volts into them. So that's a problem. Buck converters are very efficient, on the other hand. So one of the things that we're going to do is we're going to plug in this buck converter, and we're going to take our 12 volts and convert it down to 5 volts. And so, once again, we will take our multimeter, and so this is the input plus, input minus, and output plus and output minus. And I've actually hooked it into this this barrel connector here. which I think should plug into this. It does. Fantastic. So once I get 5 volts on the output here, I should be able to power this board with it. So let's see that. Let's connect these up. And connect this up. Where is my screwdriver? And don't ever do this with actual live voltage. As you can see by the LED down here, you could just kind of see it when it was on, but I've turned the power to this thing off. Not that it would kill you. Well, it would. 12 volts at 5 amps would almost certainly do some real damage, but not that this is likely to kill me doing this, but better safe than sorry. I would rather not die today. Okay, so we got our buck converter hooked up, so you can see just on the edge here. Got it all wired in, and we're once again going to set the multimeter to measure voltage. And I think I've already set this buck converter up to output 5 volts, but we will see. Hope nothing explodes. And as you can see there, I have 5.034 volts DC on the output, which is excellent. That's actually exactly what I want. That's a good start. Alright, we'll turn this off. And very quickly drain the power because there's actually a load on it now. And that means, so if this wasn't outputting 12 volts, this here wasn't outputting a consistent 12 volts, what I would do is I would take the screwdriver, and there's this little tiny kind of screw thing right here at the edge, and I would either tighten it or loosen it depending on what voltage I wanted. I would attach a multimeter to these two like I did before, just to see what it's outputting, and then I'd twist the screw on here to adjust that. And so I've done that before. And for the buck converter, what I've done is I've taken again a multimeter, attached it to these two, and I've turned this screw right here, that one on the top there, until it read about 5 volts. Very exact process. But this means that this board should get power. Now I'm not sure, I don't believe that I have... Oh, I do, actually. There's a Leonardo right here, which takes 6 to 12 volts, I believe, actually. I don't believe I have a board that shows it's getting power, but I can possibly see if I can fix that here. So this should be getting power now and not explode. Oh, excellent. There is a, yeah, you can see the green LED right here. The board is getting enough power. And the blue LED here for the buck converter. One that puts load on the system, which is good. That's what you want. And two, it shows that the buck converter is actually working. So, excellent. I have 5 volts going to the board from a 12 volt power supply. That's a good start. So that's one problem solved. Now what about the other problem? So the other problem that we had, if you remember, was, let's see if I can find, where did I put that, I'm just losing everything. Here it is. The other problem that we have is that this doesn't have a signal wire. If I want it to go in, I supply 12 volts to it. If I don't want it going in, I don't supply 12 volts to it. So how do I, like, make this board supply 12 volts to this when I, you know, clearly, if I do any output on any of these, they're going to be 5 volts. And that's not nearly enough to trigger this. It's going to have to be at least 6 volts in order to trigger it. So how do I fix that? Well, the answer, let me detangle some of this. Where is my screwdriver set? It's over here. So in order to detangle this, I'm gonna have to grab my screw bits. Bits? Yes. There we go. Give me one moment while I kind of undo my previous project here. Because this is the only one that I have. Alright. So, this is the Adafruit, I think? No, SparkFun. This is the SparkFun Beefcake. And this is what's called a relay. This allows me to safely trigger higher voltages from a lower voltage. So let's say that I have 12 volts that I want to, or let's say I have 100 volts or 110 volts or 240 volts if you're British, that I want to run through this. And I want to turn that 120 volts, 110 volts, on and off from a 5 volt Arduino. This is the best way to do that. So what I do is there's 3 pins, I guess, 3 things on this side. Sorry. There's 3 things on this side that I use that plug into the Arduino. So I have the positive, I think. Let me see which one's positive here. Not that it matters. Alright, we have the positive, or 5 volts. We have the ground. And in the middle we have the signal wire. Now, signal wire is what actually does the work here. The signal wire tells this relay to turn on and off. Or to switch, actually. And so what we have here is we actually have a switching power supply, or a switching relay. And we have, on this end, we can stick 110 volts if we wanted. In this case, it'll only be 12 volts, but we could, if we wanted to, stick 110 volts on here. And we have a common, a normally open, and a normally closed. And so what we're going to do here is we're going to use this relay to basically break the flow of electricity from this 12 volt power supply to this Maglock. We're going to use this to break the electricity flow, and then to unbreak, I guess, the flow of electricity. And so that'll actually tell this to move in and out, essentially is what we're doing. So with this we have the common, and the common is your hot or neutral, it doesn't really matter. And then you have your normally open and normally closed. So normally open means that in its rested state, when this has no signal going to it from the signal wire here, when there's no signal going to it, normally open means that the circuit will be open. Open circuit means that no electricity will pass through. If your circuit's open, then there's no electricity going through it because it's a broken circuit. Normally closed, or NC, so this is the normally open, normally closed, NC, right here at the top. That is when this has no power. This circuit will be closed, and it will let electricity pass through. So you have a closed circuit. And then when you put a signal into that, this normally closed will switch to a normally open, and this normally open, or this normally closed will switch open, and this normally open will switch closed. So you can kind of do whatever you want with this relay. You can have a you can have it so that way if there's no signal, then this is out, or if there's no signal, this is in. So it, you know, however you want to do that. In this case, I don't normally want this to consume electricity, so I'm going to say, so yes. No, in this case, sorry, I want this to be locked in its rested state, and then I only want it to open for a set amount of seconds, and then I want it to close again. So normally this will be in its rested state or with no electricity. So in order to hook this up, I want this to go into the normally open, so the normally broken circuit. So I'll do that now. Let me get a slightly better head for this. There we go. It should be a little bit better. It's still a flat head, but it'll work. So the thing is, I have two wires here, and you know what? How do I plug these in and have this common still in there? Well, really, what you want to do is you want to plug the neutral in, or ground, I guess. So you plug your ground in. Oops. He says, swapping out heads again. You plug your ground in like normal. So that way, when you break this part of the circuit, then you're breaking the flow of electricity from the hot to the appliance and then back to the neutral or the ground. And then when you're closing the circuit, you allow that flow of electricity back through there. Think of this as like a kind of a loop where electricity comes through here, this hot, and then it goes through the wire, through the wire, through the wire, and then into the appliance, and then back out again through this neutral. So if you break that flow anywhere along the line, then it won't work. It'll stay closed. So we can kind of break it anywhere. I'm breaking it on the hot. Some people like to break it on the neutral or the ground. It doesn't really matter. It doesn't normally matter. There can be some circumstances where you have, say, a servo, and if you break it along the hot rather than the ground, you risk introducing backfeeding our RMF. RMF? Wow. Electromagnetic pulses through the wire. I don't believe that's called RMF. I think I'm just having a brain fart. So in this case, it's fine. There's no servos involved. There's no magnetic influence that can happen. So you can use whatever. Just be careful if you ever do this on like a servo or something, especially a servo that's running. If you just break electricity to it, it's gonna feed back a bunch of electricity through the wires. And what you can do to solve that, or one of the things that you can do to solve that, this isn't a perfect solution, but you can use one of these, a Zener diode, which only allows electricity to flow through one direction. If it catches electricity flowing through the other direction, it stops it. Although again, it's not a perfect solution due to reasons that I won't get into now because it's kind of a lengthy discussion. But for now, it doesn't matter, and this will work. And so I'm going to want to throw this into the common. Screw this down. There we go. And screw it into. You can connect multiple things to the same port. I call it port, but it's really just electricity. You can connect multiple things to the same thing that provides electricity. Because of course you can. You can plug multiple things into your wall outlet, right? This is just a little bit more hacky and a little bit more janky than your everyday extension cord. But it still works fine. That's maybe gonna see a couple of sparks from that, but it'll be fine. Okay, so we have our relay set up with our Maglock, and now it's time to plug in the Arduino. So I have a couple of wires here. Let's see if I can find one that works. That'll have to be male to male. Got a yellow signal wire, which will be any of those pins. It doesn't really matter for now. And I need a hot and a neutral. See if I can find one somewhere around here. All of those are female to male. I mean, I have plenty of wires. The problem is the various colors. I like red for hot, and I seem to have run out of red somehow. Ooh. Excuse me while I drop all my equipment. I like the colors red and black for hot and neutral, and I found a black. So there's that. I don't see a red, so I'm gonna say orange is close enough, and I'm going to make a mental note to do some shopping on Amazon later. Alright, and so now we grab our bit. And a slightly wider flathead. And we're going to connect this up. So we've got our ground, our live, and our signal. So hopefully this guy is labeled. And we have ground, and then 5 volts. Yes, these two are actually 5 volts. On a normal Arduino, one of them is 3.3 volts. On this particular model, it is a 5 volt supply. I'm going to plug this into the ground, then plug this into the ground. So now it's grounded. And now we plug the hot in. Five volts to 5 volts. And finally, signal to signal. Now it doesn't actually matter which it doesn't actually matter which pin I plug this into, as long as it's a digital pin, which is this entire section here, so I can plug it into any one of these. PWM does not matter for this. If I sent this a PWM signal, it would be very confused. So we're just going to plug it into 7. I believe that's 7. It's kind of hard to read. And plug this into the signal. And there we go. It's all wired up. Get this off of the case because Worst case scenario, the ground is going to dump electricity through this. Well, worst case scenario, it dumps electricity through the case, but it really shouldn't since I have the ground connected through here. But I would rather keep these pins away from the case anyway. Okay. Let's make sure this is all on. There we go. Excellent. Okay. Put away the stuff for now because we're going to do a little bit of coding. So now that we have all of that set up, it's time to actually do some programming. Because we're going to have to actually, you know, send a signal through that wire. So this is easy enough to do in the Arduino language. What I'm using here is actually Platform IO, which as far as I can tell is the best IDE that you can use for Arduinos. This is the Platform IO IDE extension for VS Code. I really like VS Code, and Platform IO is probably the best extension that I have, or the best way that I've seen to actually code anything Arduino. It's seriously good, and it just works. It's really nice. Not having to use the Arduino IDE is amazing. Anyway, let's get the setup here, and we're going to serial.begin just because I do want some output. 9600 baud rate. And do I have a USB-C cable that I can use to plug that in? I'm sure I do somewhere. I'll find one. And we're going to set up our pins, which, what is that function called? Set, I think it's like set output or something, set pin, or like pin mode. Hey, it knows what I'm trying to do. Pin mode, so digital pin 7, I think that's actually D7. I can just use that. And then our pin mode will be output. No, D7 doesn't exist. I guess it's just 7 then. Or is it digital, oh, DD7? I wonder if it's DD7. Port pins, yep. Cool. So that's pin 7, and we're setting it to output mode. And in our loop, we are going to, I mean, this is a super, super simple program. We're literally just going to delay for half a second. We're going to set the, I'll just say like, output equals true. Output equals not output. And we're just going to say pin, what is it? Oh, how do I do that? It's how do I do pin output again? It's not pin mode. It's pin something. Take a look at this real fast. Arduino pin output. Oh, digital write. I'm sorry. Wow. I knew that, but it just kind of escaped my brain for a moment, so, and that was a moment too long. It was time to Google. So digital write, pin 7, and then we're going to write high. Or actually, we're going to write output. Output high, low, sure. There we go. Very, very simple program. And let me grab a USB-C cable so that I can actually program this thing. Because this is a very special Arduino that runs on USB-C. Because why not, I guess.
Let's go have some fun.
Okay, I grabbed my charging cable, or one of my charging cables that I regularly use, but I think these should work. I think these do have data output. We'll find out. If it doesn't, I have another that I know for sure works. Just have to dig a little bit more. See, cables work in, USB works in 4 dimensions. You twist it around and it doesn't work, so you twist it around again and that doesn't work, so you twist it around one more time and it works. Sometimes it's a little bit painful. Let's unplug this. Hey, that was a good sound. Alright, just verify that this actually does compile correctly. I mean, I assume it will, but you never know. And, oh, you know what? It just about reaches, too. If I do this carefully, I might... If I get a 6-foot cable, you know, that would probably work a lot better, but this might work, too. Go. Okay. And we will serial.println our current output state. We'll just write state because that makes much more sense. And then output. Just recompile that, make sure it does compile. Excellent. Upload it to the board. Hopefully that works. It usually does. And it does. Fantastic. Oh, I was very confused. Right, okay. That's already working. It's supplying 5 volts to this thing, and that is a really loud click. Man, that scared me for a minute there. Here, let's, there we go. Perfect. So it is actually working, but let's test it on this end. Look at that. It's really loud, but it does work. Wow, that is a loud click. I mean, again, this beefcake relay is kind of designed for really high voltages, like 110 volts. But with that, we actually have this thing moving in and out with just our code here. So let's turn this off and unplug this because it's going to drive me nuts otherwise. All right. That wasn't too bad. I think I'll take a look at the RFID as well. So the whole point of this is to basically badge in, kind of have this RFID badge that when you scan in your RFID card or wristband or whatever you want, it will check against our internal system here, which is actually just the Arduino. And if you're good to go, then it will open this lock, and if you're not, then it won't. And so that part's relatively easy. I do have some code that I've pre-written for another project that I'm basically going to kind of copy over a little bit. So one of the things I wanted to do is add inside our dependencies MFRC522, and then MFRC522 is the library name, but it's actually the name of this chip here, or this board, but it's actually the chip inside the board that's doing the controlling for this. And so we'll have to wire this up specifically in a particular way, but which we will do now. But at least I have the library that I can use. And so in the main.cpp, I'm going to include our MFRC 522.h along with SPI, because this actually works on an SPI level. You can see our MOSI and MISO pins here. You can kind of just barely read it, but you can see our MOSI and MISO, or our master out slave in and master in slave out pins there, which indicates SPI. So we do actually have to include SPI.h into our includes here. I think MFRC 522 does include it, but I'm not sure. Alright, and now we will wire this up. Let me just pull up the wiring guide here just to make sure I've got everything correct. Okay, and you know what's interesting is I believe, yes, so this particular card actually takes 3.3 volts, not 5 volts. So that's something to pay attention to. I believe, again, this board only does 5 volts out. So I'm going to have to grab either an Uno that does 3.3 volts, or maybe a Leonardo. Oh, Leonardo, there we go. Which I believe, yes, there's the 3.3 volt pin there. Now let me just double check the power requirements for the Leonardo, because I think the Leonardo actually takes 6 to 12 volts, not 5 volts. 5 volts is actually undervolting the Leonardo. So Arduino Leonardo power, or volts, or voltage. Okay, let's, oh, I was gonna say bring that over so you could see it, but I'm not recording the monitor, I'm recording just that on screen. Alright, so operating voltage is 5 volts, but the input voltage, recommended input voltage, is 7 to 12 volts, and the input voltage limits are 6 to 12 volts, or 6 to 20 volts, I'm sorry. So what's interesting about this setup is if we decide to go the Leonardo route, we wouldn't even need this buck converter here in order to convert from 12 volts down to 5 volts, because the Leonardo happily operates in that 6 to 20 volt range with the 7 to 12 volts recommended. So 12 volts would be on the end of that recommended spectrum. So this would actually convert it down for us. We wouldn't even need this, which is actually kind of excellent. So that's an option. Another option that I did want to take a look at was, well, I mean, this guy, but I'm not sure what the, if it can supply any power on its end. I know its operating voltage is 5 volts, but I'm not sure what it can do on, yeah. I don't believe I can connect SPI either, or if I can, then it's through these tiny pads here, and I don't really want to do that. I do have an official 3.3 volts TNT 4.0, and this operates purely on 3.3 volts. I have to feed it 3.3 volts, so I'd have to take this buck converter and convert down to 3.3 volts if I were to supply input voltage to it. But it does operate purely on 3.3 volts, which can be an issue with this, because this operates on 5 volts. And what will happen is I'll supply a 3.3 volt signal, and it will just be high enough to trigger this, which means that if there's any transients on the line, it's going to completely screw this over, and this will like constantly be triggering on and off. One of the ways that you can defeat that kind of thing is using a specific board that translates between 3.3 volts and 5 volts, which I do actually have, so that is an option as well. Unfortunately, I don't have a regular Arduino on me at the moment. I do have regular Arduinos, but they're at the lab, and since we're all on lockdown, I can't go grab them. So I'm going to have to kind of compromise. Another option is this Wi-Fi board, which is essentially a regular Arduino, and I believe could supply our 3.3 volts out. I believe the pinout is similar, if not the same, just in a different kind of configuration. So I believe this does supply 3.3 volts, and additionally, I could use the Wi-Fi chip on it to connect to an online service or something and check credentials that way, rather than storing it on the database in here. So that is another option. And that might be the closest option that I have to just a simple, 3.3 volts out for power. I mean, another option is, once again, I use another buck converter. Yeah, I didn't mention, sorry, but I thought of, is I use another buck converter to convert down to 3.3 volts here, and then use the rest of these for 5 volt communication between the board. It's interesting because all of the rest of these pins do operate on 5 volts, but the board itself operates on 3.3 volts. If you feed it 5 volts, it'll explode. So that is another option. I can buck convert and feed it 3.3 volts. And yeah, I think that's all of my options, because I don't actually have, I don't actually have an official Arduino Uno, and this one, or I do, but again, it's at the lab. And this one is 5 volts only. So I don't know, what do we think? What's the best option? What route should I go here? Should I go the buck converter route and just plug this in directly? Or should I use one of these other alternative boards and use a 3.3 volt power supply or power output on the board to this guy? What do we think? Out in chat, I mean, sorry. I'm sort of leaning towards the keep it simple stupid and just buck convert down to 3.3 volts for this board, just so we can kind of continue on and plug this thing in. But part of me does eventually want to maybe connect this to Wi-Fi to pull like online resources or something. So maybe this board would be good too, since it's actually about as close as I can get to the Arduino Uno, aside from maybe the Leonardo here. The fact that it runs off 5 volts and that it can supply 3.3. I think those are my two best options, but I'm not sure exactly what route to go. Tell you what, actually, here's an idea. I'll leave it up to a poll, since we're getting close to an hour anyway. I want to, cut the stream eventually here in a few minutes, and I think what I'm going to do is I'm going to leave this up to a poll. What board should I use for this project, and how should I take this 3.3 volts? And we'll see what everybody votes, and then I'll come back tomorrow, I think, and kind of finish up this project. And I'll swap out, in the meantime, I'll swap out the board that I would like to use, or I'll use the buck converter, or whatever kind of people decide on the poll. I think that might be the best kind of the way forward here. I'm not impartial or partial to any one of these. It's just I think maybe the easiest route would be the buck converter or this Wi-Fi board. Well, the most long-term route would be this Wi-Fi board. The easiest route would be the buck converter. But yeah, I think I'll kind of leave it up to you guys. We'll end the stream here, and I'll come back with yeah, part 2 of this, basically, where we finish up this project entirely, and using the new board that I swap out, or the new method that I swap in with the votes in the poll. So I'll send that out in chat. In fact, I'll create the poll right now. It's strawpoll.me. Still exist? Is that a thing that people still use? Oh, we're using it. What method should I use for the 3.3 volt issue? Sure. That's close enough. And I'll add more context in the YouTube poll, I think, as well. So one option is to buck convert 12 volts to 3.3 volts. Another option is to use, let's say, the Leonardo board, and skip buck converting entirely. Another option is to use that ESP board or the Wi-Fi board. So use the Wi-Fi board. See if I think there should be a let me just double check to see if there is a 3.3 volt option on this thing. Reset. Yep, there is a 3.3 volt, and that's pretty close. So use the Wi-Fi. Whoops. Use the Wi-Fi board. Future. And then use Wi-Fi for a future video / update. And then finally, I think my last option that I even want to provide is the Leonardo Wi-Fi, and then use a purely use the what is it, the Teensy 4.0 board, buck convert to 3.3 volts, and use a level shifter for 5 volt.
You know what? Let me hit that.
There we go.
Really? I can handle it.
And we'll allow multiple poll answers.
Come on, smoked a ton of weed in the 90s.
Yeah, there we go.
Right, the 90s.
And there we go. Okay, so I'll go ahead and vote if you would like to. And I'll post that on YouTube as well. And we'll see what people would like to see on the next stream. So I will see you guys tomorrow for the next stream, and we'll finish this project essentially. I think I'll have the first time in a long time 2 streams in a row that are actually, you know, consistent. So we'll have to see. It'll be interesting to see what everybody thinks as well. So, all right. Hope you guys had fun. And we'll finish this tomorrow, I think. Enjoy.